Empirical formula calculation. The steps to doing this. First, we will start with the number of grams of each element given. Then we convert the mass of each element to mole using molar mass. Then divide each mole value by the smallest number of moles calculated. And then we round to the nearest whole number. So let's look at problem number 1. In problem number 1, we are trying to find the empirical formula for the compound that contains 13.5 grams of calcium, 10.8 grams of oxygen, and 0.675 grams of hydrogen. So those are our given. So let's first find out what is the number of moles for calcium, oxygen, and hydrogen. So we're going to write down what is given, 13.5 grams of calcium, 10.8 grams of oxygen, and 0.675 grams of hydrogen. We know that we need to find the molar mass of each one of these. So 1 mole of calcium is equal to 40.08 grams of calcium. So 1 mole of oxygen is equal to 16 grams of oxygen. So 1 mole of hydrogen is equal to 1 gram. Let's solve for this. First, we're going to eliminate the common unit. So in this case, for calcium, we can eliminate the grams. For oxygen, the same thing. And for hydrogen, the same thing. And that just leaves us with the moles for each one. For calcium, 13.5 divided by 40.08 will give us 0.3375 mole. For oxygen, we will get 0.675 mole. And for hydrogen, we'll get 675 mole. Now, the next step is to divide these moles by the smallest mole. So in this case, 3375 mole is the smallest number, 0.3375. So I'm going to divide all three of these numbers by 0.3375. That will give us 1, 2, and 2. So therefore, we can write out the empirical formula for this compound as Ca, there's 1 of that, O, there's 2 of that, and H, 2. And remember, we do not keep this 1, so we're going to rewrite this formula as CaO2, H2. And that is our formula. So the molar mass of calcium is 40.08. We know that oxygen has a molar mass of 15.994. I'm going to make that 16. And we know that 1 mole of the molar mass of hydrogen is equal to 1. So we're going to use that. We know that hydrogen has a molar mass of 1. This problem give us our composition in percentage instead of gram. Since these compositions add up to be 100%, we can automatically translate them to equal to gram. So 57.14% will become 57.14 gram. Similarly, 6.16% will become 6.16 gram, and so forth. So first thing we're going to do is we have to determine the number of mole. And so we have to take these given and divide it by the molar mass of each of these elements. So let's go ahead and do that. So I set up dimension analysis for each of these elements as given. So for 57.14 gram of carbon, the relationship is 1 mole of carbon to every 12 grams of carbon. And we found that by looking at the periodic table. And for hydrogen, 1 mole of hydrogen is for every 1 gram of hydrogen. For nitrogen, for every 1 mole of nitrogen, we have 14 grams of nitrogen. And for 1 mole of oxygen, we have 16 grams of oxygen. So when we solve for this, we got 4.76 mole of carbon, 6.16 mole of hydrogen, 0.68 mole of nitrogen, and 1.70 mole of oxygen. So the next thing we need to do is we need to divide by the lowest number of moles. So in this case, the lowest number of mole is 0.68. So when we divide by the lowest number of mole, we got 7 mole for carbon, 9.05 mole for hydrogen, 1 mole for nitrogen, and 2.5 mole for oxygen. Now, in this case, the 9.05 and the 2.5 is not whole number. Now, there's a rounding rule that we observe. So if the decimal to the 10th place is a 0.1 or 0.9, we will either round it down if it's a 0.1 or 0.1 or less, or if it's a 0.9 or above, we round it up. So in this case, for 9.05, since the 10th decimal place is a 0, we will round this down and make it into a 9. However, in 2.5, the 10th decimal place is not 0.1 or less, and it's not 0.9 or higher. So in order to solve this, we will need to multiply it by a multiplier that will bring this 2.5 to a whole number. So in order to bring this to a whole number, we're going to multiply everything by 2. And when we do that, we are going to get another number. So that's 14. This is 18. This is 2. And this is 5. So now the number of moles is 14, 18, 2, and 5. So that means that the empirical formula is C14, H18, N2, and O5. And that is the empirical formula.